We probably have the longest panel table in the forum, so hopefully the stage can take 10 of us without collapsing. And what I'm going to do is I'm going to let all the panelists introduce themselves. I'll start with Will, only because you picked the seat next to me. And what your name, what company you're with, and I'm going to probably ask them all the question as far as what are the kind of solutions, your philosophies or your company's philosophies, and how you help your customers reduce unscheduled downtime and at the same time, help increase their KPIs. So I'll start with you, Will.
Okay. Hi, I'm Will Getz with Emerson's Reliability Consulting, and that's Reliability Consulting. So I'm a consultant, which I think is a little different than most of the folks you've seen up here today. Emerson helps our customers achieve top quartile reliability. And of course, we do that from the device level up. So great devices to measure pressure, temperature, flow, the networking capability to deploy those devices with wire or without, the systems to gather that information. But from a reliability consulting perspective, we provide the capability to bring that information together to drive reliability performance. And the two most important metrics that I think people should think about when they think about reliability at a plant level, those are mechanical availability and maintenance cost relative to replacement asset value. And top quartile is measured against those two metrics. So in the top quartile, you see about 2% downtime as an average in the top quartile. And you see very low maintenance cost RAV. So just for perspective, the fourth quartile would be seeing probably 3.5 times the maintenance cost of the first quartile and about 14% more downtime. So from a business perspective, the ability to make that transition is huge. And as we look at IIoT coming in and enabling access to information, right, to drive the cycle, the maintenance cycle that improves the efficiency of plant performance, I think what you'll see is that that's just another method that's moving into a well-established model of how maintenance should use condition information to get in front of failures and to mitigate those failures, lowering the cost of maintenance and the amount of downtime for any potential failure. So.
Okay, great. I'll pass the mic to Phil.
Thank you. Hi, I'm Phil Cooling. I'm with Schneider Electric. We have quite a few products in our portfolio that deal with SCADA and HMI, as well as applications that deal with this area of downtime management and production management. We're observing a couple of mega trends that are influencing the way that we're tackling these problems. One is the dramatic shift in the cost of I/O by several orders of magnitudes. We've been seeing this week with IoT. So the numbers are truly staggering in terms of the amount of data we can bring into our systems. And the second mega trend we're observing as well is the demographic shift that's going in many of the customers across industries across the world. We're seeing many people, if you look around the conference this week, you see a lot of people baby boomer age are retiring out of the industry, being replaced by people sometimes 20, 30 years younger. So we have a training issue as well in many of our industries. And so a lot of what we're focused on, and you saw from the presentation today as well, people are still very central here. So although we can apply automated algorithms, anomaly detection, fault detection into the process, in many cases, we still have people, human beings involved in the process. And so what we're really focused on is how do we take all of this data, these millions of data points, and turn them into meaningful information. What we're focusing on is an aspect of this called situational awareness for our customers, where we're trying to move from this just raw perception of all of this data that's coming in and turning it into something where the users of the systems can project what will happen if I don't do something or if I do something. So if you think of an industry neutral example of driving a car and you've got a teenage family member who's driving a car, you tell them they have 3 liters of gas in the tank, that's totally meaningless. It'd be meaningless for most people who are driving. If you give them a gas gauge and you say to them it's quarter full, you've got a little bit more information. If you tell them they have 50 miles driving distance to empty if they keep going at the speed they're driving, you've got very clear, actionable information. So we're trying to put those kinds of things into the box and make sure that's the kind of information that's available to users. So they have a projection of what's going. We see those kinds of things as very critical to downtime avoidance, building displays and getting information which are contextually relevant to startups for cleaning cycles, recovery from unplanned downtime, and really putting people at the center of this. And a big part of this is actually taking data out of the problem. So removing that volume of data from the screens. In the history of this kind of process control display, SCADA and HMI systems, we've been putting information on the screens. Now we're trying to take that information off and make sure it's very, very aware. So that's a big change we're seeing.
Okay, great. Robert, he'll borrow that one.
Rob Soder, and I'm with Rockwell Automation, and our watchword is connected enterprise. We're enabling it for ourselves, and we're enabling it for our customers, for smart machines, having more and more intelligent diagnostics on the machine, getting more and more data into the system to troubleshoot and solve problems, improving downtime situations, and also the aspect of safety, as Jim talked about, to improve the downtime aspect as well as the machine safety itself. And then security. So we're building more and more secure functions into the controller itself and into the end devices like drives and I/O.
Okay, and Travis.
Hi, I'm Travis Cox. I serve as the Director of Sales Engineering for Inductive Automation. We make Ignition. It's our software product for HMI, SCADA, MES, and IIoT. And basically, the platform is really about connectivity, getting connections to a lot of different devices and bringing that in. So the more data we have, the more we can do with that information, especially in relation to OE and downtime. And then to deliver that information to more people. We have a licensing model that allows that information to get to people in their desk, at the plant floor, and mobile devices. So the idea here is to get all the information, be able to turn it into meaningful information that we can deliver to more people at once.
Okay, great. I'm going to have a question that we'll start with all the speakers, and then we'll let the panelists have a follow-up. And the question for all of you is, what were some of the issues that your biggest obstacles to success? What kind of hurdles did you have to overcome, to achieve this reduction in unscheduled downtime and increased KPIs? And what were some of the solutions that you had to deploy to overcome these obstacles? So we'll just start from here. We'll start with Dan and Craig.
Yeah, my biggest problem was Craig.
Right.
Now, the big thing, we've got 6 plants, we've got multiple lines, we've got varying levels of commitment at the different plants on who is actually utilizing the systems that we put in place. At the Cincinnati plant, we had very, very little issues because it was actually being pushed by the ops guys. It was fully embraced by everybody at the plant. At other sites, we've got issues where we've had systems in place for a year and a half that really aren't utilized effectively because they're not, A, understood by the end users, or B, pushed by the plant management to really use it. That's something that we're actively addressing now, is really getting traction for the other sites. What do you think?
Yeah, Dan covered most of it. Coming from an operations standpoint, to me, the challenges are, selling it to the team and getting them to buy in and use it every day, over and over and over, and it becomes routine. It becomes your daily direction setting. So that's the challenge for managers mostly. And on this project, it was an easier one because we were all engaged in solving these problems and improving. But even this project over time, without someone knocking somebody over the head to keep it going, and sometimes that was Dan sitting at his desk, and we'd look back and he'd say, "Oh, did you have your meeting today?" But it takes a driver, and generally I'm that guy. But it was nice to have Dan by my side, sometimes knocking me over the head. So
Great. Clark?
Yeah, for us, I think a couple of the biggest, obstacles that we had to overcome was we have lines from many different years of manufacture. We got lines that were built in the 80s, and lines from the 90s, and we have brand new lines that have a lot more capability, but we had to somehow normalize the system across all of them so that it looked the same to the operators. At the end of the day, we could report on the same things and we could show them the same screens so that the same KPIs could be measured across all of them. So we had to do a lot of different strategies to, either connect up new PLCs to the lines or to use different methodologies for communicating with these older lines. The newer lines were generally much easier. The second really big thing for us was we had to do a lot of meetings about how we were going to get data and use data, because we had all these different, ideas of what's it going to do for us when we install this new system. And so we had to just do a really great job of scoping the project to a manageable chunk before we began, and really know very clearly how we intended to achieve each of these objectives. Having done those two things, the rest of the project really wasn't that hard. And we were really shocked at how fast it's paid back and, led us to want to continue to do more.
Okay. Jim?
I guess I'd say probably the biggest challenge would be more of the same related to reporting. It's kind of the garbage in, garbage out a little bit when you're trying to figure out why the machine's down. So you need a system that's collecting data, that's reporting what the issues were and collecting data, and try and keep the human element out of it. We maybe at 3M have too many data collection systems and stuff, and trying to get down to the best ones that work the best for us, and trying to take the human element out of it where something happens and then the operator picks a category and enters it into the system. And by the time it gets to the people who are trying to diagnose what's going on, it's probably not good enough anymore to do that quickly and efficiently.
Okay. Joe?
Yeah, I think our biggest concern, or when we were trying to adopt initially and get that support for adoption, wasn't necessarily from management because they could see the value, but really was from folks in the field understand, or some skepticism from those folks that you wouldn't sacrifice quality or reliability in terms of system improvement. System performance was important, but they didn't want it to impact quality and reliability, which is really what they view they're judged on. So now that we have, over a year and a half of system running with the upgrades, they're probably some of the biggest advocates we have now for that approach, and really spreading the word to their peers at other sites in terms of the possibilities of the new approach.
Okay. And from the supplier perspective, again, how are you advising your customers based on some of the obstacles that maybe you have seen, and how are you advising them to get over some of these big obstacles? And I'll start with you, Will.
So I think in our experience, the number one obstacle is changing culture and people to a different model, to move away from firefighting and stop rewarding firefighting and maintenance. And I think that the number one approach, the most recognized approach to doing that, is to have executive sponsorship. And really, I think the only way to get to executive sponsorship is to have a sound business case that they buy into. And so when you put those things together, you can start the process of moving to a different way where you actually start to use information about asset health to schedule and plan work into the future.
Okay. Phil?
Yeah, very, very similar from my perspective as well. Our projects are normally confronted with initial skepticism that a new approach might actually solve the problems or be better. It's often followed once the project starts with scope creep, which I heard here is wanting to take on too much, not defining the goal. So skepticism that anything will work to suddenly want to do everything, and trying to find the right place in the middle. So appropriately defining goals, knowing for the business what you expect to achieve with the system before you start, helps constrain the decisions as you go through the process.
Okay, Robert?
I find that the business has changed significantly and that people like Jim, the guys that are doing the control work, are now network experts. They're responsible for safety. They're responsible for energy consumption. They're responsible for mechatronics, the mechanical systems that are associated with the controls. And it's a big training challenge for to be a controls engineer of any depth in any one of those factors. So that's a big challenge that we try to help with. The other thing is helping with communicating life cycle of the machines. It's hard to justify upgrades and improving downtime of these machines because they are pretty reliable and they are well supported, but comes a time, and we need to be prepared for that. So feeding information in terms of where we are in the life cycle of these controls is critical.
Okay, and then Travis?
Yeah, I think two of the challenges that we try to help with, one being get the most accurate data possible in the system, and that comes with, just kind of change the model sometimes. For example, with OE tracking efficiency, having a counter on a PLC that just rolls over versus having reset at shifts, we can accurately track that. So if the system, the latency went down a little bit, that we can get the right count, or looking at getting the automatic downtime start and end, so at least what the accuracy of the time, and then we can look at downtime reason codes later to see what was actually happening. So the challenge on getting the data accurate first, being in the system, is garbage in is garbage out, as everybody says, and second, buy-in is incredibly important. Time and time again, the operators kind of see these kinds of initiatives as a way to be a big brother over them, or a way for them to maybe drive their bonus or whatever, and it's usually having to understand the key business objectives as to why we're putting systems in place, having to understand and get them to be a part of driving the company's growth and driving the efficiency there. So getting that buy-in and letting them be part of the system versus something that's forced in on them, getting them to see what would they like to have, and getting their input always makes the system a lot better. So I think driving from those two perspectives are really important with these kinds of systems.
Okay, great. We've reached the end of the session. Please do me a favor and give the panel and the speakers a round of applause. I think they did an awesome job.